So we're going to use what we have here to find average value. Remember, that was area divided by the length of the interval. And when we go here, yeah, and when we go here, we're going to do the same thing. So the average value of a function, right, on a given interval. So in math, you remember, mean is the same as average. So if you have, 5 test grades, you want to find the average, that's the same as the mean mathematically. All right, so what does it mean to find average value? If you've got a function, right, and let's say you want to find the average value of this function from A to B. All right, so take a look at the values of this function. Here the value is y equals some number, and then the y value goes up, 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 and then it starts to decrease and decrease right here, right? So there is a change in the values of this function. Well, what was the average over this time interval? That's what we have to calculate now. And by definition, okay, average value of f is equal to 1 over b minus a times f of x dx. Okay, so let's think about this for a minute. What is this? The integral a to b f of x dx. Physically, what is that? What do we find when we do that? The area, right? So that's the area. And now what I'm doing is 1 over this. What is this? This is the interval. So this is still the same as the area over the interval. Okay? But now I'm doing it using integration. Okay? So every time you're solving a problem and it asks you to find average value or mean value, it should just be a trigger, right? It should be a trigger where you just do this. Okay? Go ahead. Okay? So, find the average value of blah, blah, blah. So don't come to me on the, with your test and say, I'm not sure what you're looking for here. What I'm going to say is, well, it looks like you have to find the average value. Okay? But it should be a trigger. Average value, 1 over b minus a, integral a to b, blah, blah, blah. Okay? Yeah.
So in the previous test, you get enough photo and...
No. You need to know. Yeah. Okay. So this is a two-part question. This is the first part of it. Let's just do that first. So here we have an f of x on 0 to 3. Okay. Average value is equal to 1 over b minus a. The direction there matters, right? 3 minus 0, not 0 minus 3. And then 0 to 3, 4 minus x squared dx. You can put parentheses or not, it's the same. The dx binds it. So what we have here is 1/3. And then in brackets. Okay, so if I integrate this, right, the 4 will become a 4x minus what over what? X cubed over 3. And that's going to go from 0 to 3. Okay? So this is 1/3. Now I'm gonna plug in the 3. So that's 4 times 3, 12 minus 27 over 3. Minus, I plug in the 0, and I get 0 minus 0. Okay, raise your hands if you're not okay with how we did this. Yeah. I had an x squared and I integrated. It's the antiderivative. So I add 1 to the exponent and then I divide by the resulting exponent. Question?
You wouldn't do that to the 4 though?
I did do it to the 4 because it was x to the 0. Yeah. Now you add 1 to the exponent, it becomes x to the 1 over 1. It's the antiderivative. You integrate or you find the antiderivative. Those are synonyms. Okay, so here I have 1 over 3 times all that will be 3. So that's equal to 1. So that's the average value. So 4 minus x squared, right? What is 4 minus x squared? What shape is that? The square root of 4 minus, it's a parabola. It's a parabola here, opening down. And now we want the value that, okay, so we're looking from 0 to 3. Okay, and 0 to 3, that goes like, it's down here somewhere. So basically, it's this portion, and you see how the values are constantly changing. What I just found is the average value. On average, what was the value? So it's like, summing up all the values and dividing it by the total. Okay? All right, so that was the first part of this question. The second part of the question is, at what point in the interval does the function assume the average value? So look at this. The highest value that this takes is a 4. The lowest value when x equals 3 is -5, right? So the y values, go from +4 to -5. All right. On average, it's got a value of 1. And now it's saying, was there a point where the actual value equals this average? Is there a point here where the value is actually y equals 1? Yeah. Okay, so you have to find that now. Okay, so we say f of x is equal to 4 minus x squared. We want this f of x, the value, to be 1. X squared is equal to 3. X is plus or minus root 3. There you go. At what point in the interval, right? Negative root 3 is not in the interval, so I just say x equals root 3. Okay? All right. Okay. So here we go. Mean value theorem for integrals. So what we did here, we found the mean value. Okay, the average value or the mean value, they're the same. It's actually a theorem, guys. Mean value theorem for definite integrals. So it says if f is continuous on a to b, then at some point c, f of c is equal to 1 over b minus a f of x dx. Okay, what is this telling you? In calculus, all of the theorems, if you think about them even for a little bit, okay, they are all common sense. They all make sense. So is this true? This is saying that if f is continuous, then there has to be a point where its value equals the average value. Does that make sense to you? It's got to be that way. If this is your function and it takes on all these values, well, there's got to be a point in here somewhere where it equals the average, right? There is no other way to look at it. It's like duh, and that's the mean value theorem. Okay, it's so famous. It's got its, it's got an acronym, MVT, right? Okay. Questions here? So this is the mean value theorem for integrals. All right. So let's stop this here. So this homework then, in its entirety, should be complete for tomorrow. We meet again tomorrow. G period is switched for H. So we meet again.